There we go. So we're recording now. So welcome to Talk Math with Your Friends. This is going to be recorded and flung up to our YouTube channel when we're done. Today's speaker is Rob Eby. Rob is a former colleague of mine who works at Blinn College in Bryan, Texas, which is really close to Texas A&M College Station area, if you're familiar with Texas at all. He's going to talk to us about writing memos in his math courses, which we're excited about, but there are a couple of things I want to tell you about before I pass it over to Rob. One of them is that Rob is going to use some breakout rooms. So in just a minute, I will be pasting to the chat a description of the breakout rooms. They're sorted by class. And so you can choose which room you'd like to be sent to. I'm going to have to do that manually for each person here. So if you can type in the chat window what number of the room you'd like to be sent to when we get to that part of it, that would be really useful for me. The other thing is that we try and keep these talks really, Rob's putting on his mask. We try and keep these talks really interactive. So if anyone's willing to stay unmuted and be one of Rob's featured friends, anyone willing to volunteer for that job. You just have to answer his questions and laugh at his jokes. It's not that much pressure. Come on, someone.
I can laugh at jokes.
Excellent, Lauren. That's awesome. Thank you. If anyone else wants to be that type of person for Rob, that would be splendid as well. BK, I think, is going to be monitoring our chat. Did I forget any of my other important announcements? Okay, that sounds good. Cool. Well, we will pass it over to Rob Eby to take over for us now. Rob?
All right. So that everyone feels appropriately safe, I am wearing my mask and I have my hand sanitizer. So we're good. All right. And actually, if you're like me, hold on, where'd it go? There. And can't stand your ears. Share.
I like my ears very much. I don't know what you want to do with them.
Can't stand the mask pulling on your ears.
Oh,
then
that's something different.
Sorry. The if you didn't notice that you can get on Amazon these mask extenders that save your ears for pretty cheap. And I've found that also with masks of different lengths, it helps tremendously. But anyway, and then all these slides will be posted on the website later, so whatever. So this is a variation on a talk I gave for the AMATIC conference. AMATIC is the American Mathematical Association for two-year colleges. So we quickly came up with an acronym for that. That normally happens in November. This November, of course, like most everything else, is not happening. Maybe online. They're working on that. It'd be free online. It's a lot of fun. Blinn College is a two-year college. So anyway, that's where this is and all that stuff. And as Kate mentioned, later we're going to have a choose your own adventure, so to speak. And so just be thinking about which particular one you want to go to. And it's okay if you don't particularly have, but that's where the questions are aimed for anyway on that. So a little bit about Blinn College to set the stage, because we're a little unusual for a two-year college. So as Kate said, we're basically next door to Texas A&M, roughly 28,000 students on our campus. And then we also have some other campuses, and almost all of them, as you can see, will transfer to a four-year institution. Most of them to Texas A&M, but there are others that they'll transfer to. And as you can see, we have a huge number of sections of various classes that we're teaching. So this fall, I think it's actually more than 23 calculus ones. I think it's up to 28 calculus ones. And we have an engineering academy agreement with Texas A&M, where basically we teach almost all of the freshman classes for their freshman engineering students, except for engineering 1 and engineering 2. But they're basically A&M students. They can live in the dorms, join the Corps, do all the athletic stuff, but they're taking Blinn classes, which is good for us. But it also makes this weird dynamic going on, because roughly, by surveying them, my students and some of the others, roughly half of my students, even in Cal 1 or Cal 2, have had calculus before at high school, whether it was AB or BC or just calculus of some kind. And so I wanted to come up with a way to sort of, well, slap them around a little bit early in the semester, so that they would realize they didn't really know calculus and they're really going to have to work at this, so that we didn't have disaster happen on the first test. The other major thing I wanted to, come on, there we go. Okay, is right. You never learn something really well until you have to explain it to others or teach it. And in learning how to explain, especially in Texas, at least, they're multiple choice tested a whole lot in high school. They're not really asked to explain a bunch. And so having to explain stuff is a new concept, especially to a non-technical audience. So as I tell them, most of you want to be engineers. Most of you, the engineering firm will have a sales force who are not engineers. So you're going to have to explain to that sales force what it is you're doing and how to sell your product, or even your boss who may or may not be an engineer. And so, and I actually impose a word limit on it, and mainly just so that they focus on what they're going to say, right, and be concise about this. And unlike projects, so I like to do writing projects, big, fancy group writing projects, but those take a while to grade. And in particular, and I'll get to this here in a bit, when we were forced to go to a learning management system and individual submissions, that group projects individually submitted became weird and cumbersome. And then it allows me to sort of farm out a bunch of questions and not have to worry as much about students having the one, the stereotypical 3 smart kids find the answer and everybody copy. And then it's, in my mind, writing and communicating is a valuable skill that's being lost. And I call it the testing generation, the multiple choice testing generation. We can gripe about social media or whatever else, or kids these days, back in my day, which is hilarious because, as I joke, the reason my name's only 3 letters long in each position is because I couldn't spell it correctly if it was any longer. But there we are. The other thing is this piggybacks off Spencer's talk last week. It's a way to kind of get around my department grading limitations. So my department, for a number of reasons, some good, some we have a lot of rules about how much each of our components of the class have to count percentage-wise. And when I approached my assistant dean and dean about, okay, is there a way I can shoehorn mastery grading into this and kind of explain mastery grading, the basics of it, I got one very blank look and one look that said, you'll have to talk to the vice chancellor for academics. And so I said, okay. And yes, you're reading that correctly. They could have 4 exams, a final exam, and that's 80% of their grade, and online homework to get up to 95% of their grade. And that's how you can test them in Cal 2 and Cal 3. So Memos was one of my ways to get around this. And we actually, as it says, we're structured to only 4 exams. So in my Monday, Wednesday, Friday Cal 2 class this semester, I can only have 4 exams. Yeah. So here are the sort of the basic rules they've evolved. I did them as groups of 2 at first, but then a couple of weeks into the semester, after the first one, I ended up breaking them up individually and having them turn them in. And so, right, they're limited to 150 words, but they can use as many pictures as they like. And then they have to submit it to the Dropbox, and I tell them how to count words in Word, for instance, and for their reference, there's 94 words in these rules here. So it gives them an idea of what they're looking at and their sort of working framework with this. Okay, so right, cite your sources, all that stuff. So some of the places I got some of these ideas, concept questions from not only the Hughes Hallett, but lots of others who've written clicker or concept questions. If you're not familiar with this book from the MAA, it's probably 25 years old now, but it's a really nice resource for alternative, not as easily Googled questions. And then, right, or every time a student just, so my students have learned about a month into this class that when I suddenly stop and start scribbling in my notebook of notes, oh crap, are you coming up with another memo question? Yeah. But it'll be for next semester, don't worry. Okay. Right, or just put a basic parameter in there. It is interesting to me how much throwing a letter into the problem just throws students for a big loop. And I should be used to this after however many years of teaching, but it still doesn't. Or my usual trick is to ask them about odd even. So for example, we'll get to that here in calculus here in a minute, but right, so some pre-calculus questions, some example memo questions. So these would be 4 different memos that they would be writing, right? How does the horizontal line test apply to just those points, which drives them bonkers because they want to start drawing a graph. And then, so this one, right, I'm trying to get them to think about the idea of inverses or reflections across y equal x. And so when you reflect a horizontal line, you get vertical, vice versa, sort of a thing. I really like this one because there's, in a sense, no right answer. It's how they defend it, right? And so that gives us a chance to talk about context and domains. Okay, is it reasonable to have negative x values or not, sort of a thing. Right, and then in terms of transformations, right, this is always a fun one for pre-calculus students to wrestle with. Or calculus, right? So if I know f prime is that, if it's an even or odd function, what does it, the derivative at negative a have to be? And what I discovered, which was interesting to me, I guess I should have known this, how many of my students would say, oh, well, for x squared or x cubed, it's true, so therefore it must be true for everything. And again, I guess I should have known this, but it was surprising to me how many of them thought that one example made the proof. And so that was a nice, interesting discussion point, and it actually became a fairly useful springboard for why mathematicians have this certain perspective versus, say, engineering have a certain perspective. Which became a useful sort of discussion, right? So here's a example student answer. I got the permission to share anonymously here. So interesting idea, approach, that they'd be reflected across the y-axis, and right. And so again, these are first year students, so this is not a proofs class, but I'm trying to aim at their understanding and ideas. And so, right, this gives me a chance now to bounce back and say, okay, how do we critique this? Is this true? Sort of a thing. Here was another one, right? And we talk about, well, did you really state anything, or did you just restate the question and give one example? And somebody, if I'm going too fast, somebody holler at me. I have this annoying tendency to get ramped up in my talks and then get going. Okay, so this one really surprised me. How many of my students basically, so I'll let you read the question, right? Basically, I'm trying to get at the idea that limits are something more than, oh, you just get closer and closer to a particular value, right? There's some other things going on there. But what was really interesting to me is how many of my students would say, oh, well, the square root of 2 is 1.414, so sure. So this is an example as student answer, right? You'll notice that it never equal an exact 1.4, the desired value. And so we'd have discussion on irrational numbers and stuff, and the students, well, so what is the value of square root of 2? Oh, it's 1.414. Or they'd grab their calculator and read, and that's it. And so it was interesting. We talk about context and discussions and whatnot. So I started asking, well, what's the value of pi? And a large number of them who grew up in Texas said 3.14. I dug into that. The grade level testings in Texas all say for any geometry problems for pi, use 3.14. And so they've been sort of conditioned in that culture, I guess, that, oh, pi is just 3.14.
Didn't they try to pass a law to that effect?
That was Indiana. It was actually exactly 3. Because if you go into 2 Kings and you look at the description of the basin in front of the temple, it said it was 3 times as long around as it was wide. And so therefore, obviously, pi is exactly 3. Yeah, I know way too much about that question, but yeah.
It was horrible to read.
Yeah. So this was interesting to me, and digging down, it actually, we had a lot of aha moments when we started talking about square root of 2, never-ending, irrational sort of a thing, and suddenly students going, oh, that explains why on that homework question I wasn't getting it right, because they weren't, in their mind, all numbers terminated after a finite number of digits. which completely new to me. I guess I should have known this. So this is one of the nice things I was getting to discover early on, some of these misunderstandings that students had about stuff, right? Or so here's another one, right? It said basically, oh, square root of 2 is 1.414. Yeah. So this was I like this one in part because you can use it both in statistics and in Cal 2, right? Sequences or averages. And what's interesting to me is how many of my students would say that, oh yeah, you're going to have to approach a max, you're going to eventually hit the maximum of 100 because you're always increasing your grade score, and say, well, no, wait a minute, it says no worse than. Well, yeah, that means you're always scoring better. Okay, let's talk about this, right? And it gave a nice chance actually to talk with students about the difference between conversational English and mathese, as I say, and what we mean about these sorts of things, which was interesting, right? And they're like, oh, and so, right. Anyway, or this one, boy, it caused all sorts of fits with my Cal 2 students, which was actually really interesting. We spent a half day's class discussion about this, which I thought was productive, but make sure everybody gets a chance to look at them and get a feel for it, right? Whatever. The number of confusions on students' parts between the limit of tangent going to infinity and arctan going to infinity was huge. I got answers of pi halves in both cases, sort of a thing. There it goes. Right. But it was also interesting to watch. A lot of students would do squeeze theorem, especially with sine, right? They'd say, oh, well, with -1, 1 sort of thing, what's happening? And then they try to do that with tangent or arctangent and would sometimes be not as successful. Right, and then you can do a similar thing with e to the whatever. And I'll tell you that this one, number 2, the 1 plus e to the -x, really caused them fits, time of the convergent function, because they kept wanting to say, oh, well, it has to converge. I say, well, it's a little above 1. You know, how do you know? Oh, and so it really was a useful discussion for what does it mean to converge, and can you be a little bit more, and it tied back to the P series, right? And any exponent just bigger than 1 will converge but won't, sort of a thing. It was a nice sort of back and forth about, oh, okay, whatever on this stuff. But as you can see, right, these are non-standard sorts of questions, I choose to kill my students, so to speak, on these out-of-class memo type questions or project type questions, whereas the in-class exams and stuff are a little more straightforward questions. In part because, right, that's the stuff they experience with, in part because due to some department rules and transfer rules, we have no calculators allowed on any of our exams, which means that writing word problems is very interesting. So anyway. Okay, so if you haven't yet told Kate or in the chat where you want to go ahead and pick your room. And then I think in the chat, these links are posted, but I made them tiny little URLs. And knock on wood, if I got the Google link set up right, these should open a PDF. And so each room's going to have a separate problem here. We'll take, I don't know.
Yeah, you guys are welcome to go look at the questions real fast and see if you want to change rooms. And then maybe about a minute, I will press the send you to your room button.
I don't know. Let's give them, I don't know, 5-7 minutes, Kate, or so.
In the rooms?
Yeah.
When they get there, that's fine. So far, I think everyone's chosen their room and seems happy with it, except for Chad and Sandra. If you guys want to pick a room before I press the go to your room button. Gosh, I need one of those at my house. Can I get one of those at my house, like a go to your room button, and just, and the children just.
You could, Kate, you could rig up one of those Staples easy buttons just so it says something else.
He's so good. All right, Sandra says any room is fine. Chad, do you want to pick a room before I press a button? Maybe he's not totally there.
Sorry,
and you need a narrator.
Late, so I'm figuring it out.
No, you're totally fine, Chad.
So each room.
When you guys get there, you can, when you guys get to your rooms, click on the link and then you can discuss the problem at hand. And then we're gonna come back and do Rob's math memo wrap up. Is that right, Rob?
Yeah, so I'll have the
each-
questions again on a slide. So you won't have to remember the question. Everybody will see the question and what that you're staring at, but just basically to have the group sort of give a consensus of what you came to and what the thought process was behind it, or any other things that you thought of, right? Because I'm always looking for ways to extend these or whatever too. So
Yeah. So also while you're in your rooms, you guys talk about who wants to report back and take volunteers. And I'm gonna go ahead and open all rooms now.
I guess it looks like everybody's back. All right, so do we have a spokesperson from room 1 here? Whoops, where?
I'm the spokesperson for room
Okay.
1. So, oh, and you're putting it up. Great. Okay.
Yes.
So we first off started by making some assumptions that we assumed that the function was continuous, which mostly we just assumed that the only error was the printer's error and there wasn't also like some point way off the screen.
Yes,
or
yes, yes.
something that we had to assume. And we started with the function or the integral farthest on the right because it was the easiest to think about. And so for this one, we were just looking at the area between the x-axis and the curve, between 0.25 and 1. And we noticed that even if you had it go as negative as you possibly could in the printer's error, the area of that blob that is under the x-axis is smaller than the positive area that we can see. So we can say that that integral is positive. For the middle one, well, for both the first one and the second one, we used fundamental theorem of calculus, part 2. So, oh, my video just went away. So we said that this integral is the difference between the function. Yeah, so we got that it was negative because it's the difference between the function at 0.25 and at 1, and the top of the error is below it at 0.25. And then for the first one, we did the difference of the derivatives, and the derivative at 0.25 is 0, but at 2, it's pretty negative.
Yeah, so my usual hang up that the students have is they don't think to do fundamental theorem. They want to talk about that, well, let's see, f double prime, so it's really concave down there, but it's not as
To
concave
be fair,
down.
Rob, that was my exact thinking too. It was like people started talking and I was not listening because I was like, but like concave this way and concave that way.
Yeah, BK, I think, was the only person who thought of that right away.
Yeah, well,
and smart kid in our group who helped us out.
So actually, this is one of the things I stress when I introduce the memos to the students. Is I say, oftentimes, all I'm going to have to do when you come to me and you can't think of anything at all is I'm going to draw one little picture or one little thing, and the dominoes are going to fall, and you're going to go, oh. And so I tell them, look, this is one of the things I'm trying to do with this is train you to sort of step back and think about all different perspectives, because sometimes getting the right perspective is really important to make your life a lot easier, right? Rather than just knee jerk, oh, this is a problem, do it this way. This is a problem, do it this way. So, all right, do we have group 2?
Yeah, I'm gonna talk for group 2. So we went straight to a picture, which is part of why I am the person talking, because I was also drawing my own picture. So initially we just drew the top one and we're like, okay, so we have a rectangle and it's under some water and it has a center and we know there's some formula and it should matter. The depth is what should matter. And, you know, length times width is 1 and we can figure this out. And then someone, I forgot who, pointed out that it could be rotated. Which also meant that we could have a little corner sticking above. I don't know how well my camera's picking up my iPad.
Yeah, so basically like these, yeah.
Yeah, but also it might not be underwater now,
Right,
right? Rotation now means that the diagonal could put it 1 and 3 meters above, and still have the center 3 meters below. And so I think we basically decided that we could break it up as necessary and figure out a function of the width as opposed to with depth and something with an angle.
So the difference between professional mathematicians and first-year calculus students is the first-year calculus students just throw their hands up and say, "Oh no, I couldn't do that."
Yeah, we also decided that our students would like probably get as far as drawing the not rotated version and may or may not get as far as figuring out that even without knowing the width that they could still figure it out just from knowing the area and the fact that it was a rectangle. But even if it had occurred to them to rotate it, they would certainly give up.
Yeah, so actually most of mine, even if I restrict it to square, will not rotate it.
Yeah.
And I don't know if y'all have seen those discussions or not, where if you look at elementary school geometry textbooks, almost every example of square is like that one shown on the screen. Right. So then this is again one of those cases where I start drawing this and you can hear them start cussing under their breath and hardly ever, at least as I recall, has a student even thought of the idea that if you squash the rectangle enough, you could have it poke above the water. Usually this is enough to convince them to go, oh, but it's a nice discussion point at that point to say, okay, right, perspective and depth and whatever. And then we talk about, oh, that one's right, invariant under rotation. And so we could do it for a circle. Right, because then they'll start, well, can we do it for triangle? Oh, wait, no, we can't do it for equilateral triangle because you could, yeah. Again, right, sort of a different sort of a thing. Okay, room 3.
There was no room 3. I was the only one in it, so I left and joined room 1.
Oh, well, okay. So I will note that I tried to give the room a break, that there's 2 equalities here, but you can actually do almost all of those. And the restricting the data to 4 or 5 numbers is the one of the keys here, right? So you get students playing with it, and then you can have a nice discussion about, okay, so which one's more resistant to outliers, mean, median, or mode? What's going on here? Sort of a thing like that. All right, so room 4.
All right, so we talked about this. The first thing we talked about was the fact that we can imagine students just needing a lot of time to figure out what this is asking. There's the which of the following is or are not a possible value, the sort of the not, the negation, and the wording just is going to take them a while. We also, not everyone noticed at first the comment that the drawing is to scale. Some other things about that might be partly about knowing their instructor at this point, like the options being Greek letters instead of alphanumeric, and the choice of B as the slope here, right? So a lot of students.
Okay, so what's my last name? EBY.
I see. Yeah.
Yes. So yeah, I'm the geeky kid in geometry class that had triangles ROB and EBY. That's why it's EB and Y.
So you weren't concerned about or you weren't intentionally trying to confuse students who want to say that a slope or a line is mx plus b, and so the b is the intercept.
Both.
Both, yeah, okay, fair enough.
Yeah.
Yeah. Okay, and so so one issue is figuring out just what's being asked and deciphering that. And then we talked about how some of these are easier to rule out than others. You can certainly tell that the slope is not going to be negative, but then figuring out the value. I think Benjamin made the very nice point that isn't quite what's here. Let me.
Well, then that's fine. But...
color. Of if you imagine as sort of a slope of 1
as your comparison point. What would a function look like if that were the slope? And then if you're on either side of it, what does the slope look like then? And that allows you to rule out some of these or most of these. Oh, but also the fact that it goes up about 10 and over about 15 could make it very easy to decide maybe the answer is 3/2 if you get your rise and your run backwards.
Right, right. So that's why that's the distractor.
Yep. But yeah, the fact that the slope has to be less than 1 based on what we have here lets you rule out everything except this one.
Yeah, and as you can see on mine, if you draw a couple of those for reference, you can put a pretty tight interval on what the slope would have to be. What's interesting in this out of this question, and so this is another reason why I tend not to give these on timed exams. The point you mentioned about just taking some time to decipher what's being asked. I don't think that's fair under a time pressure to ask students to roughly deal with that. But then once they get a hold of it, it's interesting how many of the students will want to use the x squared plus e and spend a lot of time with that and figure out that, oh, well, e and y have to be the same because they intersect, which is true, but not really pertinent at all to the particular question. And so this was a nice way, especially for my pre-calculus students, of sort of drawing them out of the testing mentality that everything in the problem is exactly necessary, and that, okay, hey, if you're going to be engineers, there's going to be a lot of information in a real world problem. You're going to have to sit down and sort of figure out what's really important in this problem that I'm really going to be able to get a handle on, and what can I not worry about, sort of a thing. And again, right, the Greek letters were just, rather than because I had B down here and E, I didn't want to have another A, B, C, D, E up there. But that's all. No, so actually you mentioned the instructor's personality. I do actually do escape rooms. That's a whole nother talk. I did escape room in my Cal 1 class this past spring with actual lock boxes and everything. And so there, yeah, I got to, they were not happy with me, let's just say. They thought it was fun, but they were not happy with me. Okay, so, oh, thank you. So the question you've probably all been thinking either recently or maybe the whole time, how do I survive the grading mountain? If I'm assigning these, roughly 5 or 6 of these per student per semester. So let me give you a little bit of background about Blinn. Right, it's a 2-year college, so they don't expect us to do anything but show up and teach. Maybe not even that sometimes. Oh, wait, that's my sarcasm. So normal load's 15 hours a semester, but most semesters we're teaching 18 to 20 hours for various and sundry reasons. 32 students per section, at least to start. This semester, because we've had 5 full-time faculty not return, either due to retirements or taking other jobs, and we're on a hiring freeze, I have 23 hours to teach this semester. So yeah, grading becomes a very legitimate concern about this. So one of the ways around this is I have the Dropbox right in our learning management system, eCampus, and I have the students submit it to a Dropbox, usually Friday night. Now the last question before then, but that way it gives them a chance to clear their schedule, whatever. And then for me, I guess confession time for a math professor, I take advantage of their innumeracy, and that there's 10,000 points available for the semester. And so these memos are 100 to 50 points each. So in and of themselves, you know, 1.5%, they add up to not quite 10% of their grade. But in their mind, they hear 100 points or 150 points, and oh wow, this is a lot of points. This is, and then as you can see, right, I grade them, so to speak, like a lot of people. If you did clicker questions, right, roughly in my case half for just even attempting it, and then it's 2 levels after that, either 75% or 100%. And I tell them this up front. Hey, this is how I'm going to grade them, and the 100% is really got a pretty good margin of error on that. Again, these are first year students for the most part. This is not a proofs class. I'm not expecting them to nail the proofs. I'm trying to open up their minds to different ways of asking questions and wrestling with questions. Because I keep telling them this, look, man, the tool, when I first took this stuff, we were barely getting rid of slide rules, which probably dates me a little bit. But and there was not this internet thing. And so now the tools that I learned with are suddenly out the window. And half the questions I did in my calculus class are trivial because of technology. And so what's really important is to try to think about, how do I bring the tools to bear and set up the right problem and ask the right questions? That's really what's important on this stuff. And then we have online homework. And for the ills of it, it's really great for the drill problems. And so that takes some of the grading load off of me there too. And as I said before, my choice of where to work the students over or kill them, so to speak, is with these out-of-class memos or other things like this. Because they've got time to wrestle with them, time to come back and ask questions, and really get a handle on it. Whereas the in-class timed exams, maybe there's one curveball question, but most of them are fairly straightforward because they're under time pressure as it is and stuff like that at that point.
Rob, I have a question for you. I know that you said, excellent. Ooh, that's dangerous. Don't tell me that before I ask. No, but the question I was going to say was, I know that a few slides ago when you were talking about the grade breakdown from your course, you said something like, 10% has to come from writing assignments or something like that. I'm wondering about what directions have you been given about what constitutes a writing assignment, and what, on what level are you supposed to grade their writing fluency, right? I mean, I understand this is not a proofs class, so that's one very specific type of writing. I'm just wondering have you been given any training about grading student writing? Are you grading their grammar and their sentence structure and this kind of stuff? Or are you just trying to squeeze out mathematical knowledge when you're reading these?
I've almost copied completely verbatim in this line, whoops, what the rules say. There must be a writing component that includes mathematical rigor. And that's up to the discretion of the, so some of this is a knee-jerk reaction to, we had one Cal 2, Cal 3 instructor who was doing nothing but 4 multiple choice exams and a multiple choice final. And so the department had to find a way to say, okay, that's really not appropriate, but they couldn't single that particular instructor out. So this was kind of an answer to that. No, so we don't have any guidelines on this. So a lot of my faculty colleagues use quizzes in class as a writing component. I tend to use the quizzes as an attendance check also. So I want to use the memos outside of class as another way to give them. And as I tell the students, look, if this is another way to build up points if you're not good at in-class exams. I've got all these out-of-class assignments. This is the place you can build up your buffer so that in-class exams you're not having to worry as much about the points, so to speak. Because I hate the points game too, but we're a transfer school. That's what they're all really worried about, because there's certain GPAs to transfer and stuff like this. So that's, yeah, so very little guidance on that, Kate. And I let the grammar kind of fly. I mean, my mother's an English major, so but I kind of, as long as I can understand them, I don't really get too picky about it.
Cool.
Other questions from anybody, please ask.
Well, since you've finished up, why don't we all unmute and we can clap.
Well, so that, yeah, that's pretty much, so there's an older links to the presentation on my blog that has a lot of more example questions from Cal 1, Cal 2, and some other stuff, and pre-calculus. And then I'm going to, at some point this semester, in my free time, I'll probably put another post. If you follow me on Twitter, I'll blast when I do, that'll have more in the discussion about this and whatnot. But yeah, we'll open up the last 10 minutes or whatever for questions here.
Can we see what the rest of your shirt work says?
I'm sorry?
Can we see what the rest of your shirt work says?
Oh.
Oh, it's so hard to read on Zoom.
So it says how the bell curve works, and then I'm over on the left side of the distribution. Which a friend of mine who's a psychology prof, right? I pointed this to him and I said, Tony gets this, and he said, well, yeah, so you're the #1 asshole in the world. Thanks, Tony. So
does the back of the shirt, is it a graph of the Dunning-Kruger effect?
No.
How the Dunning-Kruger effect
works? No. Sadly. So
sorry, Brian, you must always quote the year. It was 1999.
All right,
so
I'll stop the recording and then we can have some questions.
Sure.